Good morning, students. Before watching this video, please make sure that you have watched the previous videos on the topic areas under curves, where I have clearly explained the behaviors of the curves. So, let us start the exercise 7D. So, I have segregated the problems in such a way that since this is the dry topic, I have selected the problems from easy to complex way. So that is why the very first problem, first Roman, second problem, find the area of the region enclosed by the following curves. Y is equals to cos x, y is equals to cos x, y is equals to sin 2x, x equals to 0 and x equals to pi by 2. So, we need to find the area of the region bounded by these two curves and x equals to 0, x equals to pi by 2. So, the style of solving these problems is nothing but, so whatever the interval that are given between that limits, you find the point of intersection if any. Later on, actually take x equals to some pi by 4 or pi by 3 units or something on the x-axis. Following that values, try substituting in both the curves. Then actually we will be knowing the behaviors of those curves, and then it is easier for us to find out the area of the region bounded by the two curves. Since it is a very new topic, so you might not be familiar with dealing this kind of curves. Therefore, I request you to be attentive while listening to these classes. So, this is x equals to 0, x equals to pi by 2. I will take the interval pi by 4. So, x is equals to 0, pi by 4, pi by 2. So, I have two curves, y is equals to cos x curve and y is equals to sin 2x curve. Cos 0 is 1, cos pi by 4, 1 by root 2, cos 45 is 1 by root 2, 1 by root 2 value is 1.414. 1 by 1.414, when it divides, we will be getting approximately 0.7. And pi by 2, cos 90 value is 0. So here sin 2 into 0 is 0, sin 0 is 0. Sin 2 into pi by 4, 2 into pi by 4. So 2 into pi by 4 is pi by 2. Sin 90 value is 1. And sin 2 into pi by 2, 2 gets cancelled, sin pi, sin 180 is sin 90 plus 90, cos 90 value is 0. Therefore, we get the behaviors of these two curves. Let us take the axis now. So, the coordinate axis. This is 0, this is pi by 4, this is pi by 2. This is 0.7 and just above this is 1. Now, 0, 1 will be this. Pi by 4, 0.7. Pi by 4, 0.7 is this. And pi by 2, 0 is this. So, you just join these points. So, what is this curve? This curve is y is equals to cos x curve. Now, y is equals to sin 2x. 0, 0. Pi by 4, 1. Pi by 4, 1 is this value. And pi by 2, 0 is this value. So, this is this. So, what is this? This is y is equals to sin 2x. So, in the prerequisites we have discussed that area of the region bounded by the curves y is equals to f of x and y equals to g of x, where f of x is greater than g of x. What does it mean? F of x is the upper curve, g of x is the lower curve. So that is area is equals to f of x minus g of x. Here, so we need to find out the area of the region bounded by these two curves, right? This area. So both are intersecting at this point. So if we want to know this point of intersection, then simply we need to solve these two. Since both are y equals to, therefore solving the given curves, we get, because after drawing this diagram, actually we found these two curves are meeting at this point. So this is the point of intersection. To obtain the point of intersection, we need to solve the two curves. So since both are y equals to, therefore sine 2x is equals to cos x. So sine 2x is 2 sine x cos x is equals to cos x. So I'm strictly speaking not to cancel. If you are cancelling, then actually we will be missing one value. Instead of that, listen, what I'm doing is 2 sine x cos x minus cos x is equals to 0. So take cos x in common, then 2 sine x minus 1 equals to 0. So I am left with cos x equals to 0 or 2 sine x minus 1 equals to 0. So if cos x is equals to 0, then x equals to pi by 2. So clearly both are intersecting at x equals to pi by 2. That we know. But actually we want to know this point of intersection. For this, so we need to solve this. So 2 sine x minus 1 equals to 0. So 2 sine x equals to 1. Sine x equals to half. So we are aware, if sine x equals to half, x equals to how much? Sine 30 is 1 by 2. So that is pi by 6. Therefore, this point of intersection is how much? This point of intersection is, this is anyway pi by 4 this is. So this point of intersection is pi by 6. Therefore, 0 to pi by 6 upper curve is cos x. This is cos x. Below this, sine 2x curve is there. So upper curve minus lower curve. So area is equals to from 0 to pi by 6. 0 to pi by 6. Upper curve is, so 0 to pi by 6 are the limits of x. So dx here y dx plus 0 to pi by 6 y dx plus pi by 6 to pi by 2 y dx. Again I'm telling you 0 to pi by 6 are the limits of x. So differential operator dx. So y, what is y? Function of x only. So the next step will be 0 to pi by 6. Here there are two curves are there. See this curve as well as this curve. Here actually this is y equals to cos x graph. So the upper curve is cos x minus the lower curve is, what is this? Y equals to sine 2x. So sine 2x dx plus pi by 6 to pi by 2 y dx. Here from pi by 6 to pi by 2. So the upper curve is sine 2x minus, this is sine 2x is the upper curve and this is y equals to cos x. So cos x dx. So we know how to deal the problem from this onwards. This is equals to 0 to pi by 6 integral cos x dx is integral cos x dx is sin x minus integral sin 2x is integral sin x I know, integral sin x I know, minus cos x, minus of minus plus cos 2x by divide the quotient of x. Actually here in the derivative, actually we used to treat this to be x. Sin x derivative is cos x into d by dx of 2x. We used to do that. But here not into d by dx of 2x, by d by dx of 2x. Why? Because this is an integration. So the opposite process of differentiation is nothing but integration. If into, so multiplication is the differentiation, then its opposite process is division. So into d by dx of 2x, which is by 2. Since the process of integration is over, 0 to pi by 6 is to be written here, plus, because the total area of the region I want. So from this to this plus this to this, the total area. So now integral sin 2x is, as we have discussed here, minus cos 2x by 2 minus integral cos x is sin x. The process of differentiation is over from pi by 6 to pi by 2. Now listen. Sin in the place of x upper limit pi by 6 minus sin in the place of the same x lower limit is 0 plus 1 by 2 I am separating from the process of integration. So cos 2 into pi by 6, 2 into pi by 6, so pi by 3 minus lower limit cos 2 into 0, cos 2 into 0, so cos 0. So here in both of them take minus in common, then minus if I take common in both of them, so 1 by 2 into cos 2 into pi by 2, 2 into pi by 2, 2 gets cancelled, I am left with a pi, minus cos 2 into pi by 6, that is pi by 3 upper, so this is over. So this is minus of, therefore this will be, this is plus into minus, minus, so plus into minus, minus. Okay, sin in the place of x upper limit pi by 2 minus sin in the place of x lower limit pi by 6. So everything we have. So all we need to do is just to simplify. Sin pi by 6 is sin 30. Sin 30 value is 1 by 2. Sin 0 value is 0 plus 1 by 2. Cos 60. Cos 60 is 1 by 2. The value of cos 60 is 1 by 2 minus cos 0 value is 1 minus 1 by 2. So minus 1 by 2 into cos pi, cos 180, cos 90 plus 90 minus sin 90, so minus 1. Okay, minus cos 60 again, 1 by 2, cos 60, 1 by 2. So this is over. Next, here minus sin 90 value is 1 minus sin 30, 1 by 2. So just simplify. So this is 1 by 2. 1 by 2 minus 1 is minus 1 by 2. 1 by 2 minus 1 is minus 1 by 2 into 1 by 2. So minus 1 by 4. So here this is minus 1 minus 1 by 2 minus 3 by 2. Minus into minus plus 3 by 4. This is minus 3 by 2 into minus 1 by 2. Minus into minus plus 3 ones are 3. 2 into 2 4. So here minus 1 minus half is half only. Therefore this plus half minus half gets cancelled. So 3 minus 1 by 4, which is 2 by 4, which is equals to half. So actually the total area bounded by the two curves is nothing but half. The area of the region bounded by y is equals to x cube plus 3, y equals to 0 is the x-axis. X equals to minus 1, x equals to 2. What are they? X equals to k is the line which is parallel to y-axis. In other words, vertical lines. So therefore, I don't know what is the behavior of this. So, but actually here minus 1 to 2, the area of the region bounded by x equals to minus 1, line, x equals to 2, line, and y equals to 0, x-axis and the curve. So, the area of the region bounded by the curve minus 1, 2, x-axis and the curve. So, for which what I am doing is, I will take 1 unit on x-axis. So, x equals to minus 1, 0, 1, 2. So now this is y is equals to x cube plus 3. Now you substitute minus 1 whole cube plus 3. So 3 minus 1 is 2. 0 cube plus 3, 3. 1 cube plus 3, 1 cube plus 3, 4. Next step, 2 cube plus 3, 11. So with this, actually we can plot the diagram, area of the region bounded by the curve. So now I am plotting the curve now. This is my coordinate axis. This is my coordinate axis, and so here this is minus 1, this is 0, 1, this is 2. Here this value is this is the, let us suppose this is 2, this is 3, this is 4, and for example let us take somewhere here it is 11. Okay, somewhere here it is 11 now. Now, so minus 1 comma 2, minus 1 comma 2 will be here. 0 comma 3, 0 comma 3 is this. 1 comma 4, 1 comma 4 is this. And 2 comma 11, 2 11 is somewhere here. So if you join them, so this is the area we require, and this is x equals to minus 1. This is x equals to minus 1 is the line which is parallel to y-axis. It's a vertical line, and here x equals to 2 is this. This is x equals to 2. Now listen, y is equals to x cube plus 3 is this curve. X equals to minus 1 this curve. X equals to 2 this line, vertical line, and y equals to 0 is this x-axis. Y equals to 0 is the equation of x-axis. Therefore, this area we are required to find. Okay, so this is equals to, area is equals to, from where to where? Minus 1 to 2. From minus 1 to 2 are the limits of x. If these are the limits of x, dx I will get. If this is dx, y dx. Y is anyway function of x only. So this is minus 1 to 2. What is y? X cube plus 3 dx. Now we know how to integrate this. Integral x cube dx is x power 4 by 4 plus integral 3 dx is 3 integral dx. That means 3 into 1 dx. 3 into 1 dx. Integral 1 dx is x. So therefore this is 3x. The process of integration is over. So minus 1 to 2 are to be written here. So here 1 by 4 in the place of x upper limit 2 whole power 4 minus in the place of x lower limit minus 1 whole power 4 plus 3 into in the place of x upper limit 2 minus in the place of x lower limit minus 1. So this is equals to 1 by 4, 2 power 4 is 16 minus 1 whole power 4 is 1 only plus 3 into this is 2 minus of minus 2 plus 1 which is 3, that is equals to 16 minus 1, 15 by 4 plus 3. 3s are 9. So this is equals to 4 9s are 36 plus 15. 51 by 4 square units. Area is represented in square units. 51 by 4 square units. The area of the region bounded by sine curve, cos curve, x equals to 0 is y-axis, x equals to pi by 2. So, for which x equals to pi by 4 is what I will take. X equals to pi by 4. So, 0, pi by 4, pi by 2. So, this is y is equals to sine x curve. And this is y equals to cos x curve. Now, sine 0 is 0. Sine pi by 4 is 1 by root 2. 1 by 1.414. Approximately 0.7 we will get. Now, sine 90 value is 1. Next, cos 0 is 1. Cos pi by 4 is 1 by root 2 again, which is 0.7, and the cos 90 value is 0. So we have got the behaviors of these two curves. So now this is 0, pi by 4, this is pi by 2. This is 0.7. So just about to that, for example, you take this to be 1. Now, these are approximate values. Actually, we are nowhere concerned with the accurate figures. That is why 0.7. So 1 I am taking here. Okay, na? So you no need to take the graphs and plot the diagram. A rough sketch is what is needed to evaluate the areas of the region bounded by the given curves. So now, first let us draw the diagram of y equals to sin x. 0, 0. Next, pi by 4, 0.7. Pi by 2, 1. Pi by 2, 1. I don't want the exact sine curve is like this. Okay. So I don't want between, because here 0 to pi by 2 only he has given. The part of that sine curve is what we want to know. You just join. So join. This we are getting. The rough sketch. Okay. Now, this is next 0, 1. 0, 1 is this curve. And pi by 4, 0.7. Pi by 4, 0.7 is this. And pi by 2, 0 is this. So, if you join this. So, this is x equals to pi by 2. So, what is this? 0, 1. This is cos x. This is cos x and this is sin x. This is y equals to sin x and this is y equals to cos x. Now, so we need to know the area of the region bounded by these two curves. Okay. So here 0 to pi by 4, the upper curve is cos x and the lower curve is sin x. But from pi by 4 to pi by 2, the upper curve is sin x and the lower curve is cos x. So that is what we are going to do. Area is equals to from 0 to pi by 4. 0 to pi by 4 are the limits of x. So dx followed by that y dx. Y is anyway function of x itself. So here y equals to cos x, y equals to sin x. Y dx means y is the function of x. So here upper curve is cos x minus lower curve. What is this? This is sin x dx plus 0 to pi by 4 this area so far we get. But from pi by 4 to pi by 2 this area also we need to get. So from pi by 4 to pi by 2 This time, this sin x is the upper curve, this is the lower curve. Sin x minus cos x dx. So we know how to evaluate from this time, this onwards. All we need to know is this only. Okay, so integral cos x dx is sin x minus integral sin x dx is minus cos x. Minus of minus is plus. So the process is over. 0 to pi by 4 is to be written here. Integral sin x is minus cos x minus integral cos x is sin x. The process of integration is over. Pi by 4 to pi by 2. This is equals to, so sin x plus cos x whole power 0 to power pi by 4. In both of them, if I take minus in common, then this is sin x plus cos x whole pi by 4 to pi by 2. So sin, in the place of x upper limit, sin pi by 4, sin pi by 4 is 1 by root 2 minus sin 0 is 0 plus cos pi by 4 1 by root 2 minus cos 0 1 minus of sin pi by 2, sin 90 value is 1 minus sin pi by 4 1 by sin pi by 4 1 by root 2 plus cos pi by 2 0 minus cos pi by 4 1 by root 2. This is equals to 1 by root 2 plus 1 by root 2 minus 1 minus 1 minus into minus is plus 1 by root 2. So this is minus into minus plus 1 by root 2. Here 1 by root 2, 1 by root 2, 1 by root 2, 1 by root 2. 4 into 1 by root 2. Minus 1 minus 1 minus 2. So this is equals to 4 can be written as 2 into 2. So 1 2 can be written as root 2 into root 2. 4 I have written 2 into 2. 2 can be written as root 2 into root 2 by root 2. So root 2 gets cancelled. Minus 2. So here, if I take 2 in common, then I get a root 2 minus 1. So this is the area. The area of the region bounded by the curve x equals to 4 minus y square. X equals to 0 means y axis. So here, this can be written as y square equals to 4 minus x. This can be written as y square is equals to minus of x minus 4. So this can further be written as y minus 0 whole square equals to minus 4 minus of x minus 4. So this is of the form y minus k whole square equals to minus 4a into x minus h. Yesterday we have discussed the various parabolas. So y square equals to 4ax, y square equals to minus 4ax, x square equals to 4ay, x square equals to minus 4ay. So all are said to be the standard form of the parabolas. Why standard form? The vertex of these parabolas are at the origin. But we have few more parabolas which I forgot to discuss yesterday, the previous video, no problem. So y minus, so here this can be written as y minus 0 whole square equals to 4a into x minus 0. That means this is 0, 0 origin. So y power even symmetric about x axis. But here y minus k whole square is equals to 4a into x minus h is also the same type kind of parabola, but shifting of origin here, the vertex is h comma k. In the place of k and h, you may notice 0, 0 earlier. Therefore, its vertex is at the origin. But here, the shifting of origin has happened. This is 0, 0. This is x, x dash, y, y dash. Here, shifting of origin done. So, capital X, x dash, capital Y, y dash. Therefore, this is not 0, 0. This is h comma k. So, here, for this parabola, this is y is equals to x equals to a. Okay. So let us compare this. So, and y minus k whole square equals to minus 4a into x minus h. Yes. Y minus 0 whole square equals to minus 4a into x minus 0. So this is nothing but y square equals to 4x parabola is there. So minus 4x. Y square equals to minus 4x parabola can be written like this. Therefore, its vertex is at the origin. That means this is the parabola. So origin x, negative x dash, y, negative y axis. So this is the, here y power even symmetric about x axis. Which x axis? Negative x axis. It is open in negative x axis like this. So here this is 0, 0. Now y minus k whole square is equals to minus 4a into x minus h. This is a parabola like this exactly by all respects, but the h comma k value, the vertex is at the place which is other than 0, 0. That means same diagram, everything, see the same diagram, but here shifting of the origin has happened, same diagram. So earlier origin is this, negative x axis, positive x axis, negative y axis, the positive y axis, negative y axis. Now this is a new origin. So its vertex is shifted at h comma k. The origin is shifted at h comma k. This is x, x dash, y, y dash. So this is the shape of this curve. So here it can be compared with this. Here h comma k value is, h value is 4, k value is 0. So 4 comma 0 is the vertex. So the rough sketch of this diagram can be easily drawn. You know how? See this. H comma, so this is 4 comma 0. 4 comma 0. So this is 1, 2, 3, 4 comma 0 is situated here. So basing 4 comma 0 to be the vertex, here y power even symmetric about x axis. X axis is acting like a mirror and open in the negative x axis. Basing 4 comma 0 as the vertex. So this is the parabola, given parabola, and here x equals to 0. So if you want to know these 2 points, which is not necessary for this problem, but if you want to know where this parabola cuts the y-axis, x equals to 0 you substitute. Simply x equals to 0 if you substitute, 0 equals to 4 minus y square. So y square equals to 4, y is equals to plus or minus 2. That means this is 2 comma 0, this is minus 2 comma 0. Again I am telling you, it is not required. Now 4 comma 0. Now this is the parabola given and x-axis, and x equals to 0 is y-axis. Sorry, this y-axis and the parabola. This area of the region we want to find. Okay. So this area of the region bounded by these two curves is what we want to know. So area is equals to now. Area is equals to from this is 0, 0. This is 4, comma 0. So 0 to 4. 0 to 4 are the limits of x dx. So 0 to 4 are the limits of x dx. Dx is followed by y dx, right? So 0 to 4, what is y? What is y? So it can be framed by the given equation. So what is this? X equals to 4 minus y square. Y square equals to 4 minus x. Y is equals to square root of 4 minus x. So this y can be replaced by root 4 minus x dx. This is equals to, we know what is integral root x. This is x power 1 by 2. X power 1 by 2 plus 1 by 1 by 2 plus 1. So this is 2 by 3, 4 minus x whole power 3 by 2. Not over x, because here treating this to be x, root x, treating this to be x, we have proceeded. Integral root x is 2 by 3 x power 3 by 2. But this is not x. We have treated this to be x. Later we have to differentiate. Dividing with this. So here d by dx of 4 minus x is minus 1. Now the process of integration is over. We have to apply the limits from 0 to 4. Please bear in your mind that 0 to 4, this area I am trying to find. But here this is symmetric about x-axis. So 0 to 4, this area I am trying to get. But here this is symmetric about x-axis. That means whatever the area I am going to get through this into 2, because actually this only we are going to get here. But to obtain the whole area, we need to multiply it with 2. So let us do that. Here minus 2 by 3, minus 2 by 3. So 4 minus x is 4 power 3 by 2. This is upper limit minus lower limit 4 minus 0 whole power 3 by 2. So here 2 by 3 into minus 1, so minus 2 by 3. So this is equal to minus 2 by 3. This is 0. 4 is 2 square. 4 is 2 square whole power 3 by 2. So this is equals to 2 gets cancelled. Minus into minus is plus 2 by 3 into 2 cube 8. 2 cube is 8. So 2 8s are 16 by 3. Please bear in your mind that this is not the required area, because so from this to this upper area is what we got right now. So to obtain the whole total area is twice 16 by 3, which is equals to 32 by 3 square units. Find the area enclosed within the curve modulus of x plus modulus of y equals to 1. So modulus means it is plus or minus x plus or minus y. That means totally we are going to get how many? Totally 4. First quadrant, second quadrant, third quadrant and fourth quadrant. So these are given curves are plus or minus x plus or minus y equals to 1. So 1 is x plus y equals to 1 if both x is greater than 0, y greater than 0, positive x-axis and positive first quadrant. So and second, minus x plus y equals to 1, second quadrant, plus plus minus plus. So X two combinations I have taken. Third. So minus minus. So this is minus X minus Y equals to 1. Fourth one, X plus Y minus X. So plus plus minus plus minus minus plus minus. So X minus Y equals to 1. See, X has two positives and two negatives. Y has two positives, two negatives. Total, these are the given lines. And this is of the form X plus Y equals to 1. So X plus Y by 1 equals to 1. X by 1, Y by 1 equals to 1. So this is of the form X by A plus Y by B equals to 1. Here both A and B are 1. That means this is the equation of the line in the intercept form. This is 1 and this is 1. So here actually the total curves will be here like this. This is X plus Y equals to 1. This is minus X plus Y equals to 1. This is minus X minus Y equals to 1, and this is X minus Y equals to 1. So here okay, so this is 1 and this is 1. This is 1. So this is positive 1 comma 0. On x-axis y coordinate is 0. This is minus 1 comma 0. This is 0 comma 1. This is 0 comma minus 1. So here the area of the region, here this is 0 comma 0. So area is equals to 0 to 1 are the limits of x-axis. Therefore dx, if this is dx, y dx is what we need to take. So integral 0 to 1, what is y? Y is equals to 1 minus x dx. This is equals to integral 1 dx is x minus integral x dx is x square by 2. The process is over. 0 to 1 is to be written here. In the place of x, substitute 1 minus 0 minus 1 by 2. In the place of x, 1 square minus in the place of x, 0 square. So 1 minus 1 by 2. 1 minus half is half. But this is area of one symmetric region. There are 4 such symmetric regions are there. Therefore total area is equals to 4 into 1 by 2. This is equals to 2 square units. Area, the second problem of the second Roman. X square equals to 4y, x equals to 2, y equals to 0. So let us analyze this curves. X square equals to 4y is of the form x square equals to 4ay. That is the parabola. So x power even symmetric about y-axis. Which y-axis? It could be the upward parabola or the downward parabola. But here y has a positive sign. Therefore it should be the upward parabola. Immediately let us try to draw the diagram. So this is what I am mentioning about. So x power even symmetric about y-axis. So that means y-axis is acting like a mirror. So y-axis cuts the entire portion of this parabola into 2 equal parts. Right. This one is over. Y equals to 0 is the x-axis. Therefore this is the x-axis. This and this are over. X equals to 2 is the line which is parallel to x equals to k is the line which is parallel to y-axis. That is a vertical line. So this is 1 and this is 2. So this is y equals to, this is x equals to 2. This is x equals to 2. This is the curve, the given curve, and y is equals to 0, x-axis this. So this area is what we need to found. So this is 0, positive x-axis, negative x-axis, positive y-axis, negative y-axis. So therefore area is equals to from 0 to, this is 0, 0, this is 2 comma 0. So 0 to 2 are the limits of x dx. Dx means y dx. Y is after all, ultimately it is a function of x only. So 0 to 2, what is y here? X square by 4 dx. So 1 by 4, integral x square dx is x cube by 3. The process of integration is over. 0 to 2 are to be written here. 1 by 4 3s are 12. In the place of x, substitute upper limit 2 cubes minus in the place of x lower limit 0. 0 cube. This is equals to 2 cube is 8. 8 by 12. So 4 table if you cancel, 4 2s, 4 3s. So 2 by 3 square units. The area of the region bounded by y square equals to 3x, x equals to 3. Let us quickly analyze. Y square equals to 3x is the parabola. It is of the form y square equals to 4ax. It is the standard parabola whose vertex is at the origin y power even symmetric about x-axis. So x-axis is acting like a mirror. So that is x-axis is acting like a mirror means it could be opened in the right side of the right side or a left hand side. But here x has a positive. Therefore, the rough sketch of this is y square equals to 3x, y power even symmetric about x-axis. It could be like this or it could be like this, but it cannot be both at the same time simultaneously. So it could be one of these two, but here x has a positive. That means it should not be opened in the negative x-axis. Therefore, this is the parabola. So this is y square equals to 3x and x equals to 3 is of the form x equals to k. X equals to k is the line which is parallel to y-axis, which we have learnt in straight lines chapter. So x equals to 3 is the vertical line parallel to y-axis. So this is 0, 1, 2, 3. So this is x equals to 3. Therefore, this is x equals to 3. This is the curve given and that's it. So therefore, this is the area of the region we are required to find. So this area. So therefore, this is positive x-axis, negative x-axis, positive y-axis, negative y-axis. So area is equals to from where to where? This is 0. This is 3 comma 0 on x-axis. Y coordinate is 0. This is 0 comma 0. From 0 to 3 are the limits of x. So basing on x-axis we are taking. Therefore dx we will get. Dx is followed by y dx. Y is after all is a function of x only. So 0 to 3. Y square equals to 3x. Y equals to root of 3x dx. So root 3, since it's the process, since it's a constant, separate it from the process of integration. Integral root x is 2 by 3 x power 3 by 2 from 0 to 3. So this root 3 times 2 by root 3 into, in the place of x upper limit 3 power 3 by 2 minus in the place of x lower limit 0 power 3 by 2. This is equals to 2 by root 3. So 3 power 3 by 2 is 3 root 3. So root 3 gets cancelled. 2 3s are 6. But do not get confused because this is not the area of the region which we are which we are looking for. So here from this to this, actually the above or below the area we got so far. To obtain the total area, since it is symmetric about x-axis, this is the symmetric region and this is the symmetric region. Two symmetric regions we have got. Therefore, total area is equals to 2 into 6, which is 12 square units. Now the area of the region bounded by y is equals to x square and y equals to 2x. So we are very much familiar with these two curves. So y equals to x square. In other way, x square equals to 4ay. It is on the form x square equals to 4ay. X square equals to 4ay is the regular parabola, standard form of the parabola whose vertex is at the origin, x power even symmetric about y-axis. Symmetric about y-axis in the sense it could be the upward parabola or the downward parabola, but it cannot be both simultaneously. It could be one of these two. So here y has got a positive sign. Therefore, the downward parabola concept is still cleared. Therefore, it should be the upward parabola. So let us quickly sketch the diagram of this. Y is equals to x square. So x power even symmetric about y-axis. So this is the parabola. And so y is equals to 2x. We are very much familiar with this. Earlier in straight lines chapter, y is equals to mx it is on the form. Y is equals to mx is the line which is always passing through the origin and it is a straight line. Therefore, this is y is equals to 2x. This is y equals to 2x and this is y equals to x square. So clearly the diagram clearly says that actually here some area is what we could sense here. So clearly this parabola and this line are seemed to be intersecting each other at this point. So to obtain that point of intersection, we have to solve these two equations. Let us solve. Solving the curves we get. The curves. Again, I'm telling you, this is the parabola and this is the straight line passing through the origin. So both are y, therefore x square equals to 2x. Again, I am appealing you, x and x should not be cancelled. So because x square, this is the quadratic expression, quadratic equation, x must have two values. If you cut these two values, then actually some values would be missing. Always it is recommended to you, instead of cancelling, you just transpose this onto the other side. So take x as a common, x minus 2 equals to 0. Therefore, x equals to 0 or x equals to 2. So this is 0 and this is 2 comma 0. This is at a distance of 2. So this is 0, 0. Therefore, area is equals to from 0 to 2 are the limits of x dx followed by y dx. Y is ultimately a function of x only. So 0 to 2 here, if you see this, so this line is above x-axis. This line is above x-axis. This is upper curve and this is a lower curve. So both are by. So here this is 2x. This is upper curve and this is lower curve. This is upper curve. Now, so 2x minus the lower curve is y is equals to x square. See this diagram. So 2x minus x square dx. If we are succeeded in getting up to this, then actually the rest of the process we are very much know what to do. Simply integration. So 2 into integral x dx is x square by 2 minus integral x square dx is x cube by 3. So the process of integration is over. So 0 to 2 is to be written here. So since it is not the symmetric about any axis, therefore into 2 or into 4 into 3, so we need not do that. So whatever the answer we are going to get through this is the final answer. So 2 gets cancelled. So here in the place of x 2 square minus in the place of x lower limit 0 square minus 1 by 3 constant in the place of x upper limit 2 cube minus in the place of x lower limit 0 it has a cube. 2 square is 4 minus 2 cube is 8 by 3. 3 4s are 12 minus 8 4 by 3 square units.